this? Okay.
Yep. Yep.
Oh. Sorry. So besides me, who else are we recording this?
You need help with the recording? I can.
I think
I am.
Yeah.
I am also recording as a backup.
All right. Great. Cool. Thank you, everybody.
Thank you.
All right. First of all, thanks everybody for joining us. We're very excited to have everybody here today. So today we'll have Emi Tanaka to give us a talk about the art of design, software, and experimental design. So before I start, I wanted to acknowledge the traditional owners and the custodians of the land on which we are. I'm on the land of Wanarujis on the Kulin Nation and invite everyone to reflect on the owners of their land, from which the sovereignty was cut. So if you like to join us, R-Ladies, you can join us on our meetup and follow us on Twitter. And if you like to give a workshop, seminar, or short talk at R-Ladies Melbourne, you could send us a direct message on our Twitter account or email us, or you can simply just leave your details and talk to us after today's workshop. So a big thanks to all of the amazing and faithful sponsors. So CSL provides funding for events and they extend their support to the next year. And Zendex NASA's provides us space and drinks for our events every time we have it in person. And we have occasionally host our events location for meetings as well. So big thanks to our sponsors. And you can find us in all different channels that we list here. So today we have a very warm welcome to our special guest, R-Ladies Melbourne.
Thanks, Dodo. Hi, everyone. Thanks very much for letting us join your event. We are very, very new. If you'd like to go to the next slide, we launched last month, and so we're very excited to have made it on the map. And I just got these stats the other day, so you can see we're very, very small, but since our launch, I think we've doubled in size, which is very exciting, but obviously are not up to the size of the Melbourne meetup, but hopefully we can grow that a bit. If we go to the next slide. We have a few NT linkages that are getting the word out about R-Ladies and are very excited about the initiative, and that's the Women's and Innovation Network NT, and I'm part of that committee at the moment, and they've become pretty active this year, and we meet once a month to talk about all sorts of things related to women and innovation, and they run all sorts of workshops and promote all sorts of activities. So I think recently there was an announcement on LinkedIn where they did something, a leadership course for women in construction. So they cover all aspects of STEAM, and they're very supportive of R-Ladies Darwin. So there's a little bit more information there if you're interested, or if you ever come up to the NT. And the other thing I just wanted to mention is that CSRO have a Young Indigenous Women's STEM Academy, and we have someone in the Darwin office, Melissa Tippo, who actually runs that academy, and we've been trying to hold some events with young Indigenous women, but unfortunately COVID did a stop to that this year, so we couldn't sort of run any events, but are hoping to do in the future. So that's a little bit about us. We're just growing and figuring out how we might work virtually, and taking a few notes from all of you. So thanks very much for the invitation.
Thank you so much. It's very good to see that we have more R-Ladies on the Australian land. So a little bit more about today's speaker, Dr. Emi Tanaka. She's a lecturer in statistics at Monash Uni, whose primary interest is to develop impactful statistics methods and tools that can regularly be used in participants. Her research area include data visualization, makes models and experimental designs motivated primarily by problems in bioinformatics and agricultural science. She is currently the president of Statistical Society of Australia, Victoria branch, and is an avid program in R, HTML, CSS, and other computational language. She's also my supervisor. We work together, and she's amazing. Can't wait for her to give the talk. All right.
Well, thanks a lot, Dai, for that wonderful introduction. I'm gonna just share my slide. And just give me some minute, just maybe to readjust my windows. Okay. Okay, so I hope you are all seeing the right slides. Yep, excellent. Well, thank you for the invitation to R-Ladies Melbourne, and congratulations for R-Ladies Darwin. I'm looking forward to seeing all the R-Ladies really grow. So today I'm going to be talking to you about software and experimental design. And just to give you an overview of today's talk, I've got really two acts. One part, in the first half, I'm going to be talking to you about software design, and I'm going to be illustrating that by drawing faces under like a programming language, using really different programming paradigms. In the second half, I'm going to be talking about experimental design. I'm going to talk to you about how to construct comparative experimental designs with the edibble R package. Now, this slide is all available online in the links that you can see on the slides. And today I have also provided all the codes that you can use to reproduce the slides that I'm showing you today. I will show the links at the very end, so don't feel like you need to write it down at the moment. Okay, so let me get started. First act, software design. I'm going to talk about drawing faces with different programming paradigms. So in the first instance, what I'm going to do is to talk about drawing a happy face, right? And so for those people who might be familiar with ggplot2, now what happens is that with ggplot2, it's actually using this package called the grid package to do the drawing under the hood. And so we can kind of think of ggplot2 as a very well thought out interface that actually does a lot of the data visualization for you, but under the hood it's really powered by using grid package to do the drawing. So let me see, I'm going to be using the grid package to draw the face. So in the first instance, I'm going to call the library grid, and there's a function called grid.circle. And here what I'm just doing is just drawing a circle with a certain radius, in this case, half a unit. Next instance, I'm going to draw eyes. So again, I'm going to call on this grid.circle functions. And in this instance, I'm specifying two centers. And this time I'm also giving a graphical parameter saying that the color of that, the circle should be filled with black. And so I got two eyes there. And I need to draw a mouse. So to do the mouse, I'm going to use the grid.curve function. And so I give in that coordinates and just have a curvature so that it's a little bit curved out. So I do square equals to false and draw, and I get the picture that you see on the slide, right? So now next, I want to draw like a sad face. So when it comes to drawing a sad face, well, it's essentially kind of like similar to what I had before, except for what I'm going to change ultimately is just the mouse part. And that's just where the curvature is going to be -1. And I have that sad face now. So overall, this style of programming is sort of what I would say an imperative programming style. So to draw this, like essentially, there's all these instructions that I am passing. And to give you like a bit of a formal definition of what imperative programming is, looked up on Wikipedia, and basically says that it's a programming paradigm that uses statements to change a program state. And to put it more colloquially, you can kind of think about it that if I do like an imperative programming style, it's more that you're kind of like passing specific instructions to the computer. So a lot of the code that you're writing is meant really for the computer to change its state. And while what I'm doing is demonstrating is not a pure imperative programming, because it's most languages that you use will have a mix of imperative programming and what's going to be called functional programming. So what's functional programming? Well, functional programming is a declarative programming paradigm where the programs are constructed by applying composing functions. So what I do is I take my imperative commands that I showed you previously and I wrap it around function. So I've got two functions here. I've got phase 1 and phase 2. Phase 1 is like the one that you saw was a happy face, and phase 2 is a sad face, essentially. So once I have it wrapped out as a function, then what happens is that I can call upon these functions to draw these faces. So phase 1, and I got my happy face. Phase 2, I got my sad face, right? And what's convenient about this is that I can kind of repeatedly use this. So if I want another happy face, I just call upon phase 1, and that calls upon a new one, right? Then I have my happy face. So rather than having to write that long commands out each time, I've got something much more convenient. So functional programming is like a certain style that's made it so that a lot of specific commands are actually all hidden like under the function. And so it's meant for more like users oriented, right? Where these functions are convenient wrappers of the imperative commands. Another one, and I have another happy face there. I could change up the design. And so part of it now next is that I can think of actually constructing my computational systems so that it is more suited for humans. So in the third part, I'm thinking of more changing up my computational systems so that it's more human-centered design. So rather than humans like us as analysts having to adapt to the computational system that was introduced, we get really the computational systems to be adjusted. So it's designed so that it's well adapted for really analyst or human use. So there's this concept called syntactic sugar. And that means that you use function names or possibly syntaxes in a programming language that's designed to make it easier for really people to read it or express what you are trying to do. So previously I had a function, I called it phase 1 and phase 2. And you know that's happy, sad face. But if I have another function called phase 3, you wouldn't be able to guess what it is, right? Like it's not something that actually tells us anything about it. And if you call it, maybe you know what it will do. But alternatively, I can rename the functions. And so I can call it like alternatively face happy for phase 1, phase 2 can be face underscore sad. And if I call instead of calling it phase 3, if I call it face underscore angry, like you kind of already have a mind before even you call upon the function, you kind of know what it's going to do. So this is making use of syntactic sugar in terms of software designs to make it more friendly for people. But okay, what if I want to draw a surprised face, or like maybe a face with eyebrows, or maybe like a face with googly eyes? So when I do this functional approach, well, first of all, just the ways that I've done previously, I can't really do that without having to write a whole new functions that really describes the totality of the face. So let me rethink about how I'm going to actually redesign my software. And then so in the next couple of designs, what I'm going to do is I'm going to use a package called Portrait. So you can install this package from this link here. And actually, this is a package. I just made it over the weekend. So it's not a very serious package. And so you can have a look around, but just know that it's not something that was done with like a serious intention. And certainly the code may not work for if you try to do it for many other kind of things. So I'm gonna use code that's available, so functions that are available within this package. So if you ever want to go back to see what the actual functions are within the that, you can just have a look up on the link that's provided here. Okay, so now I'm gonna take this and I'm going to really rethink about the way that the function was designed. And the way that I'm going to do is to really rethink by adding arguments to the function, and also reframing how I think about composing faces. So far what I've been doing is that the function names were after emotion, right? And then the emotion was a surrogate of what the total face looks like. But instead of thinking about emotion as surrogates of what the face looks like, I'm going to think of face as composed of different parts. So a face is composed of eyes, mouth, and then the shape of the whole face, right? So instead of using the previous approach, what I can do is like design something like this, where there's a function called face, and they have arguments that actually have different components to it. So I can pass in eyes equals googly, mouth equals to smile, shape equals to round, and I get the output here. So this function does work if you do run it and install the portrait package. But what if I want to extend this? So what if I want to have like a hair and a nose attached to it? Well, I can add more arguments, right? So other components of the face, I can just keep on adding those as an argument. So that's what I do. I add the arguments hair and nose, and I get my hair, a smiley face with a mohawk, and a really simple nose outline. So what if next I want to add more things? So maybe I want to add a beard. I want to add an accessory to the face. I want to add some eyebrows. The way that's been designed is that I have to add that as an additional argument. So you're essentially reliant on the developer to actually keep on adding that argument or functionality for you. So I want to bring to the last possible design, and that's really thinking of as everything as objects. So an object-oriented programming is a programming paradigm where it's based on objects that have certain attributes and behaviors. So what I'm gonna do is that instead of going from like a command straight to like actually drawing, I will think of like everything is gonna be contained as an object. And then when I'm ready, I'm going to print it out as a graphic object. So in the first instance, I'm gonna call in this function face, and then F actually is an object. It contains the information. It hasn't been pushed to a graphical output just yet. And if you look into it, what happens is that it's got certain information, like information about the shape, eyes, and mouth. So this is like a standard face if you call upon it. And if you print it, you get your smiley face onto that. What I might want to do is now start modifying this. And so I'm going to start thinking about modifying components of those facial parts. So I'm going to add this like cat shape. And so essentially what it does here, when I call on this cat shape, is that it accesses that object, changes what the shape information is, and then adds it as a cat shape instead. And so when you print it out, you see a shape of a cat. The next thing I'll do is to change the eyes. So I'm going to add cat eyes, and now I get my cat eyes. Want a cat nose. And the next, well, one critical part about cats is that they have whiskers. So I'm going to add whiskers. So like I can keep on layering, and the way that's been designed should remind you very much of how ggplot does when it comes to constructing really your data visualization, right? So it's sort of similar kind of principle here. What's happening is that you're really modifying an object and then part of the component with it. And so I can then go and add or modify parts of it. So maybe, you know, I want to have a little bit of like a chimera. So I'm going to combine like dog parts to it, and maybe also change like the colors of eyes and so forth. And so that's what I do here. Change it to a dog shape, and then I've got a cat eye with a color that's filled with red eyes instead. So what happens is that all of these functions are designed to be modular. And so what happens is that so long as you follow a certain rule that's actually required to change the object, anyone can actually add on that function. And so you can mix and match. If you don't like the way that I designed the cat eyes, well, you could write your own functions. So long as the rules are connected with the objects, you can actually have a whole new like face that you've written without having to rely on the developer to write out all the functionality for you. So like to summarize, what's happening is that in the first instance, you saw like a recipe function where like a particular function produces really one complete face. Then you can have like a function with multiple arguments, and then one function essentially can really draw multiple complete faces. But of course you're constrained, right? In terms of like the argument numbers that you have. The last part that you saw was essentially implemented like a finite number of functions, and you really have infinite possible ones. You can keep on extending it because all you need to do to add, make a new face is to maybe modify one part of the face, and somebody else can write that function. The other thing about it is that it doesn't have to be like a complete face. Like in the first instance, the face was missing nose. It doesn't have ears. It doesn't have maybe other like eyebrows, so other facial components. So it's not really like a complete set, but the way that it's allowed is that it exists as an object. It doesn't have to be complete face as is. So you can store an incomplete face as an object and only print it out when it's ready. So these are the things that I want you to remember as software design as I get to the next part when I start talking about experimental design. And all of it have a certain analogy related to the way that I started thinking about in terms of designing software for constructing experimental design. Okay, so let's get started with experimental design. And for those people who aren't really familiar with the area, well, I'll give you like a brief glimpse on the main one that I'll show you today. If you ever really learned experimental design, you might have actually learned it in a very recipe-driven approach. So there's this classical set of experimental design, and they all have like a name associated with it. So, you know, like when I learned experimental design, it went through this recipe. It goes, oh, this is a complete randomized design. This is a randomized complete block design, Latin square design, balancing complete block design, factorial design, split plot designs, and so forth. So there's many more kind of recipes on top of this, but these are really one of the very classical experimental designs. Now today, what I'm going to focus on is to talk about the split plot design. It has a bit of a layer of complexity associated with it. So it's a bit fun to talk about it. Now, for those people who are not familiar, let me give you a bit of a reminder what this is. Or if you don't know, I'll give you an introduction of what it is. So a classical split plot design, which was originally described by Ronald Fisher in his seminal book on experimental design, was based on this experiment in agriculture. And in this one, what I'm showing is I'm showing a study where we're looking at 2 irrigation methods and 2 fertilizer brands on the yield of a particular crop. What might be available for me in terms of the experimental resources is that there are 4 whole plots altogether. So in order to really study these different methods, well, what happens is that there's a bit of restriction. So I can't apply irrigation as I please. I have to actually apply it into a pretty big area, and those correspond to the whole plots. So when I apply irrigation, one principle that really Ronald Fisher promoted was the concept of randomization. So that you don't confound your treatments with the actual possible experimental setup. So what I'm going to do is have like a random application of the irrigation onto the whole plots. And what you see here is like one instance of possible randomization outcome of irrigation onto the whole plots. So I've got 2 plots on the ends becoming irrigated, and the ones in the middle are rain-fed. Essentially, it's not irrigated. Then to look at the fertilizer brands, what I'm going to do is I can apply fertilizers onto a smaller land. And so I'm creating like a split in these whole plots. And so I'm separating each of the whole plots into these subplots. So every whole plot is divided into 2. And what happens is that for the 2 fertilizer brands, I'm going to randomly allocate either the fertilizer brand A or fertilizer brand B. So here's like a result of one possible randomization that you can get out of it. So this is like a possible experiment, and the result of this will be called a split plot design. Essentially, there's a constraint in the way that you allocate your treatment, with one of the factors, treatment factor, only getting applied to the bigger unit, when then the other treatment factor getting applied into the smaller unit itself. And those constraints are due to some kind of application within the experiment. Okay, so that's the result of it. And let me talk about like R packages that are out there to design experiments. So there is actually a task view. So what's called Crown task view associated with design of experiments and its analysis. And if you look under that, there's actually 109 R packages. Now, I have given talks where I talk a little bit more detail about the popular R packages, but because I thought we won't have time, I'm going to only focus on one of them, and I'm going to only just give a quick introduction to it. So one of the most popular ones depends on which metric you use. If you use a particular metric, you can kind of regard it as like the top downloaded R package is aglicole. And so let me show you one function that associated with aglicole package, and I'll summarize what kind of like features that we see in general in the current existing experimental design R packages. So this is a particular one. So there's this series of functions that all begin with design dot. And essentially, aglicole uses very much a recipe-driven approach. You know how I showed you this like set of named experimental design? Well, aglicole tends to have like every function named after all those classical experimental designs. And so design.split is for creating split plot designs. And you can see here what happens is that I've got a function, design.split, an argument called treat1, an argument called treat2, R for the number of replication. And so what happens is that here, this argument, treat1, is fixed. You can't call it anything else. It's fixed as treat1. And every time I call this function, I always forget whether treatment 1 is the one that's applied to the whole plot or whether treatment 2 is applied to the whole plot. So one of them is applied to the big unit. The other one is applied to a small unit. And then usually I have to just look at the output. So when I look at book, I can see treatment 1 is applied to the plots. That's the whole plot. And because it's consistently equal, I can tell treat 1 is applied to the bigger whole unit. And treat 2 is the one that's applied to the smaller unit. So you can see it's in this output here, I got plots and S plots. And this is like partly aglicole was motivated by agricultural experiments. And that's why by default, it has these names. So there was no, you can see like in the function call, ever mention about what the units are. It's kind of implicitly assumed what those units are. And again, also the allocation of the treatments are also implicitly kind of done under the hood. So you never explicitly say what treatment gets applied to what particular unit. So just for your convenience, I have drawn it out here so you can see what the output would look like. And this is essentially the split plot experiment, right, that we saw before. And then you get all these kind of outputs coming from this ugly color package. The main one being the book element in the list, which has the design written out in a data frame. So this is really one of the really top downloaded R packages, which means that possibly a lot of people out there do create designs using these kind of recipe approaches. There's some other ones that I had a look, and feel free to ask me at the very end if you want to know more about it. But if I were to summarize, so common software design that you see in really the R packages, or even broadly just beyond R and maybe other languages like Python as well. So any kind of computational subsystems out there to construct experiment designs, what happens is that they have functions that construct experimental design from going from zero to really its completion. And which was like when I showed you the software design in the beginning for drawing faces, the way that it worked was that I have maybe a recipe function, or maybe I have a function with arguments, right? But the idea, a lot of those is that you go from really having nothing to really the complete picture. And so there's no like intermediate construct of the experimental design. Another part that you see very often is that anything to do with the unit, so experimental units, observational units, blocks, the allocation of the treatment units, those are a lot of time implicitly defined. You kind of don't really know, like you know that it's happening and you kind of can guess from the output what kind of allocation or what was a unit. Or maybe there's a processing afterwards where you add the units later on. So oftentimes in the code itself, you don't really keep in mind of what the actual units, your treatments you're allocating are. And also the other thing about is that your intention of what responses you're actually recording are hardly ever explicitly specified. So that's something that is probably discussed outside of the code. And so the person who's collecting the data may know about it. But code, if you look at the code alone, you don't really know what's happening in terms of the full picture of the experimental design. So coming back as an analogy of the drawing faces, a lot of the software design component of like experimental design packages really are like the earlier paradigms that I showed you. It has like a certain imperative programming style. It might have a functional programming with certain limited arguments. But I want to reframe how we construct experimental designs. And so we broke down the face before into components, right? And I want to kind of do the same thing. So totally reframe how we think about designs and construct based on a reframed version of it. So before I get into that, let me talk about certain terminology so that we are on the same page. So let me talk to you about a very basic comparative experiment. Like at the very minimal, for a comparative experiment, you really need to have experimental units. And in this case, I'll say there's n experimental units. You'll have a treatments, and there'll be maybe T of them. And then you have allocation. That allocation of treatment to units can be specified as a design matrix. And then you may decide on what an observation unit is, which may or may not be the same as experimental unit. And then for the analysis of experiment, you really need to have a record of responses. on the observational unit. Now, to be more specific, and I'm drawing this particular definition from as a modified version of Rosemary Bailey's book. Experimental unit, as defined in Bailey, is really the smallest unit in which the treatment can be applied independently. An observational unit is essentially the smallest unit in which you're measuring the response. I can have things like blocks, and those will be sometimes called cluster, depending which domain you are from. And essentially that's under what I call it also a unit. Essentially that groups some other units. So the way that I see it between experimental unit, observational unit, blocks, these are divided in classical definitions of experimental design. But for myself, I see these are all units. And essentially the function of that unit, whether it be experimental, observational, blocks, actually depend on how that, like an action of it. So if you apply a treatment onto that particular unit, it becomes an experimental unit. If you're measuring responses on that unit becomes an observational unit. If you use that particular unit to group other units, that is actually a block or cluster. So I think of it in the new framework that I'm about to show you, that all of these are actually just units. And then we have the treatment, right? And the treatment is like what describes what you are trying to apply onto these experimental units. And when I say design is essentially thinking of the mapping of really the units onto the treatment. So it's a subjective function. Every unit should be assigned a particular treatment. And then when I say plan or layout, essentially that's like the actual translation. What was the actual treatment that was applied onto the unit? And oftentimes when you say plan, there's a randomization that's taking place. Then there's experimental structure, which talks about like certain meaningful way of dividing out the units or the treatments. And so when you say it here, like, experimental structure, the units are unstructured. It means that there's no grouping that's involved. For treatment, there's a special kind of grouping called factorial, and that's talking about different treatment factors, and you're looking at combinations of those treatments. And so the combination of those treatment factors describe the totality of treatments, and so forth. So these are like the really common basic definitions of it. And you can use these to kind of describe experiment in fundamental terms. And so I took this and essentially packaged it up and thought of it as a new framework, which I started calling the grammar of experimental designs. And so this is a rethinking of how we break down experimental design in its fundamental terms. And especially it's a computational framework. So we think of it like an abstraction of the design. And I implement that kind of abstraction into the package called edibble. So one thing with a lot of the experimental design, which I find it lacks, is that an experiment really is like something that requires collaboration from multiple people. So it seems like sometimes with those R packages, sometimes it's been designed so that a statistician is in their own world with their own computer, and they somehow generate it and push it to the people to carry out the experiment. But I think that's not the way that experimental design can be successful, right? You really need to, if you want to design the experiment well, you have to really get the context of the experiment appropriately. So context is very much a key. And I'm going to be dividing like the people that's involved in the experiment into 3 different kind of acting roles. So we have our domain expert, we have our statistician who has who might be generating the design, and we have our technician who might be running the experiment and collecting the data, right? So this is not to say a statistician is somebody who's trained in statistics. It could be that domain expert might be the one creating the design itself. So, you know, just people take on that role, but they're not necessarily trained for that. And likewise, you know, what happens is that there's also possibly that multiple people can take on the same role as well. And likewise, one person can take on multiple roles. And that's like what constitutes an experiment, right? You got all these people involved, and you really, in order to have like a successful experiment, you really have to have a collaboration between these actors, essentially. So you have to extract the knowledge from the domain expert. The domain expert will tell you what the interest is, so what the treatment of interests are, what are the possible restrictions that you have in your experiments, what are some sources of variation that you got to take into account when you're constructing your designs, what some things that are like, you know, they know from the past that's not going to work, and so forth. So it's a very much like you got to have that collaboration going on between the domain experts and statistician to try to also construct a valid experimental design. And then for the technician, what happens is that they're going to run it. So they need to take the experimental design layout and make sure they carry out accordingly as the design was intended. And also likewise, putting in the role of technician to also be collecting the data. So they need to make sure they enter the data correctly as well. So when I thought of it, design, essentially it's trying to also bridge a gap between these different actors as well. So let me show you what I came up with. So to construct experimental design, let's think of it as if this is sort of like a consultation process is going on. You have a domain expert and they come to you and say, hey, I want to run this experiment to study the water resistance property of wood. So you open up as a statistician, open up your package, edibble, I'm going to start design, and I'm just going to title it as wood water resistance. So you will see the output in this corner all the time as I go through this step. So then the domain expert tells me, hey, I have like 10 boards, wood boards that's available, and I can really divide each of them into 4 small wood panels. So right, okay, I have units, I have 10 boards, so 10 levels for the panel. Well, what happens is that every board can be divided up into 4, so it's nested in the board with 4 levels. Okay. The main expert comes, I want to test the linseed oil and copper azote preservative as wood pre-treatments and 4 types of stain. So it's actually a factorial design. And so for pre-treatment, there are 2 levels. You're testing the copper azote and the linseed oil. And this is all made up, so I might be incorrect about some of the technical terms. For stain, you have 4 levels. So essentially what's happening here is that you can actually explicitly write out what those levels are, or you can actually just write down like the number of levels associated with it. So if you pass in a numerical number, a single numeric, then what happens is that that corresponds to a level. If you pass in a named vector, or not named, a vector, a character vector, those actually correspond to like the levels associated with that. Here, you know how I've got the names board, panel, pre-treatment, stain. These are not fixed, so you can call them whatever you want. So like this is partly very different to how typical experiment design packages are done, where they have a fixed argument, so you have to stick with whatever the naming is. Here, what's happening is that you're trying to make a stronger connection between what the actual context of the experiment is. So when I'm setting my units, I'm very much explicitly saying that, oh, look, this is actually, I have boards, wood panels. For treatments, I have a pre-treatment, I have a stain. And the functions don't need to be called so that units and treatment first. If you want to define your treatments first, you can also define your treatments first and define the units later. You can just see in the output, the output just shows you like a tree structure, but under the hood, it's coded up an object. So it's just outputting an object, and it has a nice print output just to show you what the current units are and how many levels you have for those units as you are going through. Next step. So the domain expert might tell you, okay, well, when I'm applying the treatment factors should be applied onto each of the wood panel. So you get the combination. So you get the combination of the pre-treatment and stain. Those are the two treatments. And then you're applying it to the panel according to what the domain expert tells you, right? So that's defining explicitly the allocation. So it's very clear. You don't have to guess, because here it's explicitly written in the code and it's not implicitly assumed under the hood as before. And you can see, notice everything is like describing things on fundamental components that I talked about in terms of the definition. But the domain expert says, oh, wait, actually, it's hard to apply the pre-treatment to the wood panels. It's too small, and pre-treatment can only be applied to like a bigger area. So we're going to apply it to the board, which means that this allocation is no longer appropriate, right? According to what they're telling us is that we're going to take the pre-treatment, and that needs to be applied to the board. The stain is going to be applied to the panel, because the stain can be easily applied independently to the wood panels. So you hear again, it's communication between the domain expert to tell you what are the constraints in terms of applying those treatments. And you're kind of writing it out in the code. So your intention, your understanding of it is very clear from just reading the code, what's happening. And then, okay, it's like, okay, maybe this is done. This is what I want. Let's do the randomization and get our design layout. So you do that, you randomize the treatments, you serve the table. So what happens here is that when you are done, so with the designing process, you signal the object and tell them, I'm ready to serve the table. It's all done in terms of the designing process. So in the previous step, what happened is that this is an intermediate construct of experiment design. It's not finished yet. Because you haven't defined all the elements that are associated with the design at the moment. And then next step in the signal, when you're ready, it produces that table. And that's what the edibble is named after. It's experimental design table. It's designed to produce this at the very end. And for those people who are familiar with tibble, it's experimental design tibble, essentially. So you can see here that we have 4 variables, which were all defined in the units and treatments. And just you can see the levels of each of them as well. And you can see the allocation pre-treatment was only applied to the board. So you can see for board 1 is consistently the same, because that's applied onto, as indicated in the allocation, pre-treatment is applied to the board and so forth. The stain can be applied essentially randomly within the board. So at this point you go, okay, you got your design layout, and the domain experiment was like, okay, looks good. Let's get the technician to come over and run the experiment. Okay, so the technician comes and says, oh, what am I supposed to measure? Well, okay, well, I'm gonna follow this paper, and then we're going to measure the diameter swelling, and then we're going to remember to record the wood supplier too. So now I'm setting the intention. I'm setting a record for the panel. I'm measuring the swelling. For the board, I'm measuring the supplier. Right. And then in the table, you can see, the intention. So here's the supplier is only measured per board. So it's like a duplicate. So you can just see crosses. So those are like, essentially, if you write it down, those just signal duplicates. So the intention of what to measure is done. But you might think, what's the point? It doesn't really do anything, right? Just besides signaling intention. Well, the technician can't come back and then say, okay, I'm going to record the swelling, and I'm aware that the swelling should be between 0 and 5 for that. So in this part, I'm telling it that I'm expecting the records so that swelling has to be numeric with value between 0 and 5. So it seems really long. And I understand that every time the code is very long, there needs to be a payoff. And so here, part of the payoff is that your intention is prescribed. So say another analyst comes over, because there's no assurance that the current statistician is there beyond the designing process, right? Somebody can take over and swap over. The intention has been specified and captured. So at least that's that. But there's another payoff to this, not just that, which is that when you write this and when you export this design, which I have done over here, the exportation actually can utilize that information that's been encoded in the object and actually encode that in the output as well. So I created an output earlier. And so this is the output Excel file. And the swelling was actually encoded. So the value that enters the swelling has to be between 0 and 5, right? So I can start recording. So the technician might start recording values. And then all of a sudden they make a mistake. And then maybe they record, say, maybe -10. Then what happens is that there's a data validation that's been embedded automatically for you, so that the data collection process has it's got more higher integrity. So like essentially you don't also misrecord a particular number. And likewise, if you try to enter a number bigger than 5, you also get an error as well. So you can actually encode these, and because everything exists in an object, like, if you don't like Excel files, you can just take that information and output it in other ones. You just can create a function that utilizes that information in other ways. So this kind of bridges the gap between, right? So when you want to run experiments, it's not just about getting the right design and making sure the sources of variations are taking place. There's the other part of experiment where somebody needs to run it correctly as you specified, and also actually enter the data correctly as expected. And I think when you get all that right, you get the more efficient and valid experiment design. So this was actually based on the example that was given here. And they talk about how this is a split plot design, but notice like when I defined it, I didn't define it by calling it a split plot design. The result is what's defined as split plot design, but I just did it purely based on its fundamental terms. So essentially, this grammar of experimental design is really designed as an abstract framework that actually thinks about mapping the fundamental components onto an object-oriented programming system to really build and modify that experimental design. Essentially, it's trying to reframe the way that you think about constructing experimental design using software. Edible's an R package, and it's implemented. It's still at the moment, there are some unstable parts where I need to test a little bit more, but you can find the current version on my GitHub. The design is to be more human-friendly and really try to get that natural order of thinking and try to encourage more explicit specifications of the steps taken to construct the design. In my opinion, the approach does actually encourage higher order of thinking because instead of thinking of names, which acts as a surrogate of the complete design, you're thinking more about it in terms of fundamental components. So you understand when you change each component, what's changing, as opposed to having distinct names. So you don't really understand what the relationship between, say, a split plot design or a randomized complete block design is. Finally, what happens is that this whole framework actually makes each of the steps modular, and you can easily mix and match methods, or you can easily extend it. You don't like one of my functions? Well, because it's been modularized, and things exist as an object, you can create one to substitute to it. And so in some sense, I'm trying to encourage more the whole experimental design community to try to leverage each other's knowledge so that they don't exist as silos. We are more coming together to share knowledge and try to leverage each other's each domain's experimental design understanding. So you can find the slides and all the materials in the link there. And just the final thing before I finish up and ask for questions. I have to wear my hat on as the president for Statistical Society of Australia, Victoria branch. And because I talked about software design, I want to remind you all that we do have like a software award. We launched the Die Cook Award. So if you are a student in Victoria or Tasmania, just keep in mind that if you have created a software around it, you can submit this, and we have like prizes as well to give. So that's it for my talk. Thank you. Any question? So from Petra, how did I come up with the name Edible?
Did I miss that somewhere?
Yeah, so it's named after definitely Tibble, which is about like a pretty tables, right? And so Edible stands for experimental design table or experimental design Tibble.
Nice. Thanks. It was a great talk. I have to race off and deal with kids, but I just want to say thanks again for letting us join, and awesome talk. And I'm going to play with that portrait package. That was very cool.
Thanks. See you, Petra.
Thanks, everyone. See you later.
Thank you so much, Emi, for your amazing talk. And I think now will be a Q&A session. So anybody who have questions related to this topic or to this edible package, please feel free to unmute yourself. And we can ask or type in the chat.
I have one question to start. Is there this is awesome, by the way, Emi. I was like blown away by the fact that you can add your names to the arguments and so on. It's really, really awesome. One thing that I was thinking, like, did you maybe you have some functions to actually plot the design once it's done, because maybe it's easier for someone to actually see that you've done all the different blocking and all the different parts. Do you have like the code for that?
Yeah, so that's a really good point that you bring up, and actually it's an extension of it. So there's a package called degust. So you can see that it's named after certain like eating things. So degusting as in degustation, and the two G's that you see there are ggplot. So the output of this is that when you define the design based on edibble, it has all the information, right? You painstakingly define all the units associated with it. So degust is still working in progress. This one is still quite immature compared to edibble, but you have one function, and that one function will automatically try to create like a best representation for you. And so you get an output like that. And because it's a ggplot object, if you're familiar with how to modify ggplot things, you can just use that. So on top of this, if you don't quite like the colors, you can use the scale function in ggplot to change the colors and other things. So it's still a work in progress, but absolutely you're correct. And this is actually, when I started this project, I thought this is actually one of the things that I definitely need, because I know as people, we tend to not like the verbose code, right? It's a lot of work to write up that code. So I thought about what is the payoff? Like, why should people invest so much in like writing this long code, which can be written as just one function in the Agricola package? And I was thinking, okay, visualization is like one of the big payoffs. And if I can automate that, make it super easy to get that pretty visualization, but also have it so that you can customize easily on top of that. So you can have a publication ready experimental layout. I I think that will help promote people using it a lot more.
Thank you. Yeah, this is awesome. So here you have the lines, because I can see, so the different circles are the unit. Looks
Yes.
from the unit, and then the fact that they have bars in this case.
These are actually like the ordering of the units. This one is a completely randomized one, so there's no structure on the units. But then because there's 16 of them, if you have it as a one long line, it's as a visualization, it's too narrow. And so I was trying to squish it, but then like I don't want people to think somehow this is somehow special to have this column. It's just been squished because it doesn't look pretty to have it laid out. So it automatically tries to align it, and then it shows you the ordering by looking through the lines instead.
Cool.
So
thank you.
that's currently the design at the moment. It might change. I think there's ways to change it. Yeah, so it's still the I think I forgot what it was. It's been a while since I looked at it, but yeah, so this was one of them. Yep, you can change it so that you can easily change it according to ggplot2 functions. Change shapes. But I think one of the thing about is that you can replace the units. So here what happens is that it's some sort of pig study. And so if you have a picture of a pig, you can replace it so the unit's actually pigs or something. So that there's an idea like this. It does work at the moment, but I think at the moment it was quite slow. So I still needed to change a lot of things internally.
Yeah, that looks awesome. Thank you. Is there any other question? I have one more otherwise, but I'll let Gorka. Oh, I could see Gorka maybe.
Yeah, thank you. Yeah, I've been playing a little bit with the edibble, and I really think that the potential is quite amazing. Kind of having a way to programmatically express designs and share them, and I mean that's really cool. So I was going through the kind of help. Now you have the documentation and so on, and I'm not sure if I just missed it, but there is a kind of examples of different types of common designs. So we can kind of copy, paste, adapt, and learn with that.
Yeah, so that's actually something I'm working on at the moment. Part of it is that I got really stretched out with so many other commitments as well. And so and then because I've been trying to work on this on my own, there's a limitation, I thought. And then I think in the end, I thought, I really have to hire somebody. So I ended up hiring somebody so that it helped me. So at the moment, my research assistant, which isn't Dai, but somebody else, who also helped me to compile like comment designs, and then also write down the translation for edibble. So I'm hoping that I can release that in maybe the next couple of weeks. Now that teaching is over, I have a bit more time to actually work on it as well.
That's awesome. Just I wanted to add if I mean, everyone is a bit stretched out and I'm the same, but if I don't know, there is a way to kind of help out a little bit, or maybe tiptoe a bit and try to test some things, I will be glad to.
Thank you. That's very much appreciated. So I think in part, I'm happy if you put in as issues. I do notice that there are some people who submitted issues on it. And I want to try to get around to as much as I can. I think it's easier now that teaching has finished. I have to say during teaching, it was quite difficult to make the time. My most productive time is actually December and January when there's nothing going on. So for Kevin, yeah, so does my package generate ANOVA tables without mean squares? Yep, so it is actually in an issue at the moment. So it's referred to as a skeleton ANOVA table by Rosemary Bailey. And definitely that's one of the diagnostic measures that I want to include. So it's in the plan, but not implemented at the moment.
So I have a question. So at the moment we did this sort of splitting into partitioning into different blocks and units, how would this package be used to implement other type of experiments such as randomized and others?
Yeah, so you could actually, so a completely randomized one is the most easiest. There's no structure involved in that. The other ones that you could do, so besides like the standard one, and then part of where I thought edibble might have a bit of a strength, but requires a bit more testing, is really also non-standard designs. So designs that actually have unbalanced replication. So here's an example where I have like 3 units at a particular site, but 2 at everywhere else. And so it can actually, if your units, when you have subunits, they don't need to have exactly the same number for every level as well. You can actually specify different levels. So these ones don't really have a name associated with designs, but I think this is also one of its strengths. But at the moment, I think my randomization needs to be fixed. So you can get the structure, which you can pipe it into other programs, but the randomization is something I need to fix a little bit more. The other one is usually the one that's actually quite complex, was the case where you have more than one blocks. So there's orthogonal blocking structure. So I don't have example written on it, but there is actually like a structure. Yeah, it's on there. A lot of them are like in the tests zone at the moment. I don't remember where I wrote it. So I have actually written some of our examples in. It's written somewhere. I have to look back. It's been a while that I actually have looked at those ones.
Okay. Do we have any more questions for Emi?
There is a question from Kevin in the chat.
Oh yeah, I answered that one.
Oh, sorry.
If not, I think that's all we have for today. And feel free to leave early if you want to, and also feel free to chat more if you like. And we have the slides and materials in the chat, so feel free to check it out. And thank you so much, everybody, for coming.
Thanks, everyone.
Thank you so much.
Thank you.
Yeah, also, Emi, I need to send you still your earrings. Probably now you should get 2 earrings now for the second talk. Now you're even.
Oh, well, thanks. I'm okay with it whenever it suits you.
Sorry?
Do you reckon you'll have I'm okay whenever it suits you. Do you reckon you'll have the R-Ladies Melbourne for the next one in person, or maybe either?
Yeah, we actually don't know, because it depends on the businesses, if they allow like how many or external people. We haven't contacted Zen Discord now. So I don't know if any one of you has, but yeah, I don't think so. It would be good to send an email. Who knows? Maybe November, I doubt, maybe. Yeah. Even, yeah, I don't know.
Have we have a date on November's event yet?
Yeah, we've decided on 29th of November. However, I'm still chatting with Maya and waiting for her response, to be honest, and I'll let you guys know.
Sounds good.
Sounds
If it's
great.
29th, it might be possible to do it in person. I think the restriction will significantly ease if all is gone, like on 24th of November.
We should probably ask. Maybe we can send an email to NAS or Zendesk and see if that would be really nice.
Given the restriction is released, do you think we should do this year's celebration like in person rather than online? Because we are trying to explore a few online options, including the escape room game. But I wonder, because now like we're looking good in terms of we can go out and book in venues and things like that. Should we just explore venue options this time? Because last year I missed it. I know you guys went out, but then I think I missed it.
Yeah.
I really miss you guys.
It's definitely tricky sometimes, because I know that especially like in December traveling, maybe you almost get more people online than in person because they
Yeah.
But it's definitely, it would be really nice to meet in person, that you get a little bit of both. I think we need a little bit. I mean, R-Ladies is a lot of networking and meeting people, so that will be a very important part. Yeah, I think if we can, we should try.
Yeah, let's wait for a couple of weeks to see when the policy is really clear and saying what's the date that we can start booking. Then that would be nice to know for sure.
I think so.
All right. And thank you for your wonderful talk. It's really lovely. I want to ask you a question, but I feel like it's going to be recorded. So I just wanted to ask you afterwards. So have you applied the package in any projects you are already doing or already done something like that? And have you had any like applications out of it? I really love to read about it.
Yeah, publication wise, I'm writing at the moment and just being distracted with a whole lot of things. I think one of the things about before getting to seriously using it, I actually need to make sure I test a lot. And so that's part of what I really wanted to work with my research assistant. And so I actually have a lot of people who expressed interest in using this, including like banking sectors and agricultural departments. So I know people are like ready to use this, but I think it's just like that person was saying, said, essentially they need examples. And then I think that's the thing, people don't know how to use it at the moment.
Like,
I only have like, I only have specific examples. And so I think people need that first initial, like a bit of a catalog to begin with, and they can see how it is. And I think it's the same, like when people learn ggplot, I know that a lot of people copy existing code first and then modify that. So I need to create a lot of the catalog first. And then I think it will. So I think I know that given my time frame, like I'm more likely to do a lot more work on this during December and January when things really quieten down. So I think I can officially have like thing on CRAN on January next year is my guess.
Yeah, and also I think it might be a little bit time consuming in the beginning, but I've seen people create packages. They do like short online courses and post it with like, for example, LinkedIn learnings and things like that. So you basically reduce the repetitive teaching training into the minimum and referring them to the same course over and over again. So I wonder if you want that to be widely adopted, and maybe that's an option for you as well. Given you are so good at teaching and training already, so I think it might be a little bit add-on work, but essentially is easier, especially, for example, a sector is going to adopt the package, then in that way is much less time consuming towards the end.
Yeah, so I'm hoping to do like a series of like online workshops around it. I got asked to actually do it. So there's actually a one coming up in about like mid-November. And I'm like now thinking, still haven't finished my back. haven't written any material for it, but I start writing it. Because actually a lot of the implementation, once you have the idea, actually it doesn't take terribly long. So like I have to say, like my major development really came down in 2 weeks, like during the period of like the January, December period. And that was like most productive time. And I got so much done on the package. After that, it's like, oh, teaching, grant writing, like, you know, Stat Society things. And I seriously had hardly any time to sit down. And I think that's the main thing that I needed. Like, I just need continuous time to devote and think about it more.
Another book is coming, so December is coming. So I'm looking forward to the new development and the new stories from the packet. It's amazing.
Yeah, I'm feeling that. I need to work on this.
Besides,
take care. I will see you guys next time. Thank you.
okay, bye.
I might need to run as well, but thanks so much. That was fantastic.
All right, see you
I
guys.
had one super quick question that I didn't get the time to ask before, but I know you died. They were asking something.
Yeah, I was going to ask her, at the moment, this package is quite dedicated to environmental designs. And the example we use is agriculture related. I'm also curious, how would this be like, what are other areas that would be very applicable with this package?
Yeah, so at the build up, I think the foundation was begin with agriculture. I think that's actually very fitting because that's how Ronald Fisher began. I can see why. It's actually a lot more easier because you don't get distracted by, clinical trials where, you have issues with people not responding, people not, sticking with the treatment and things like that. So there's a lot of peripheral issues around those kind of things. So in ag, like I'm just get to focus much more on like a simpler designs. Once I finish that, the next one is medical ones, so clinical trials. And with that one, because I lack the domain knowledge, I was gonna collaborate with Andrew Forbes to try to get going. And so that's in the pipeline, but I want to get the ag one first and deployed. So that covers generally speaking, the classical experimental designs.
Sounds very interesting.
Yeah, so it's coming, but and the idea is to try to create a framework that a lot of like domains can use, because I think at the moment, what happens is that every domain makes their own designs, like clinical trials, like step wedge trials. What's step wedge? And then there's like agriculture, it's like Greco-Latin square design. It's like like all these like domain names, and I think they don't know what each other do. And so trying to have a bit of a common base so that people can talk to each other and understand each other.
I think that's very fair. Would you be thinking cooperating this as part of the would you think the students in the agriculture science field would appreciate this kind of infrastructure?
I think, they will probably find it a little bit easier because like a lot of the components are like, it's easier than understanding names of designs, which is very, very common, I have to say, in this domain. And I think when you have to learn it, there's a bit of a barrier to understanding, but like, because this one actually makes you specify in its fundamental terms, I think it's a lot more easier to understand. Part of the thing that I did create this package for is because I did teach experimental design, and then I just thought it's so poorly done. Like I just find it very difficult to teach in terms of the coding, because a lot of the times randomization was done based on first principles, and then it's that imperative programming style. And I just thought, I think students are having trouble understanding. They're not focusing on experiment design. They're focusing on wrestling with the coding of trying to get computer to do something right. And then like, I can just tell, like, it doesn't follow nicely. And I struggled to teach it well. And I thought, oh, it's partly because you need a software that helps you think about it more.
Oh,
Yeah, sure. I had one question, but this was more about the programming side of things, because I know that you have and I have seen it in other times. So like, how does it work? Or maybe if you have some materials or something to read about making those functions where you can add, sort of that style of programming where you can add your own functions. Like, how does that work? Is there like a particular structure of the object, or how would you get started with that?
I guess the portrait one is actually quite simple, so you can have a look. So what happens with the additional one, was that one? So it really depends on the system that the developer has created. Like, for example, with ggplot, what happens is that Hadley define a particular structure. So if you want to add your own thing, you need to follow the rules that he's created. And so he has a vignette that talks about how to make extensions. It's really complex. I have to say he designed it, and internally ggplot is way too complex. So it's a bit hard to understand exactly. With portrait, it's actually, I made it very simple. And then essentially what happens with the portrait, I'm not sharing screen, am I? Yeah.
And this will be on GitHub. Yeah.
So the portrait package, essentially it's very simple. It's just a list, and then it has those components like shape, eyes, mouth, head, nose, and then it just has a class called portrait. And that's the result of it. Essentially the object is just a list, and it has a special class. Now, if I want to add on top of this, what happens is that I have utils. No, it's not utils. Where did I put it? Oh yeah, I put it in the pipe, utils pipe. So there's a plus dot portrait. And this is where what I'm doing is it allows me to add things on top. So this kind of like it's because the whole thing is just a list, and it modifies what's inside slotted in the list. And it just obeys that rule essentially to do the modification. So it's this one is quite simple. So if you want to have a look at this and play around,
I've never worked with classes or with them, because you define that list as a class. So that I guess some properties. Yeah,
there is, that's a part. So knowing a little bit of S3 helps. And then also there's a little bit of special printing. So there's a special print associated with that.
Okay. Thank you. Yeah, that's really useful. I guess, that's I'll have to do something.
If you want to know more, Anna, have a look at Hadley's advanced R book.
I was thinking about that indeed. Yeah.
And then S3 programming. It talks a little bit about it. Some people had told me that it's not quite enough. Like some parts are a bit hard to understand in terms of software design, but that might be a good starter still.
Thank you. Thank you so much.
thank you so much. It was such a great turnout today.
Sorry. What did you say?
I said it was such a great turnout.
Oh yeah.
Yeah.
Sorry about the Savandies.
It was awesome to see Petra. All right, I'm gonna go out for a walk before it gets too dark. Have a good night, everyone.
Yeah,
Have a good night.
Good night, everyone.
Bye. Thank you.
Bye.
See you.